Good morning, everyone. Welcome to 6th SAPPD 2023 webinar with the main theme AI-based and Big Data Analytics on Urban Planning and Design. Before we start, I would like to give some information related to the Zoom rules and regulations. For the first one, for all participants in Zoom, please change your name by adding your organization before your name. For example, you can see in the share screen. For the first one is MIT_name, ITP_name. For ITB students or other university student, please use the username ITB or university _ your student number _ your name. Kindly mute your microphone and turn on the video during the event. Then, for asking questions, kindly follow these procedures. For the first one, participant, please check. Can ask the question resource person only through the chat column on the Zoom platform. Second one, please check the list question that already in the chat column before asking or writing question to avoid asking the same questions. If possible, the moderator will please you to ask directly using your microphone. So please turn on your microphone later. For the last one, the organizing committee reserves the right to exclude participants who do not follow the rules. Okay, for all the participants who already inside this room, I would like to give also some information related to the standard operating procedures related to the emergency case and safety induction in this building. The first one, according to the rules from ITB and local governments, please, for every guest, must follow the health protocol. Always wear a mask, physical distancing, always wash hands with soap or water, and hand sanitizer. Especially for the one who feel not really well today, please always wear your mask. The second one, please do not smoking except in the location provided outside this building. No littering except in the trash bin. There are also some potential emergencies, which are earthquake and fire. If there is emergency occur in the form of an earthquake, please do not panic. Follow the evacuation instructions from the SAPPD officer or these building officers. Protect your head and body from falling building components. Please find a safe place from rubble or potential falling trees. And if there is a fire emergency, please follow also the officer building. Do not panic. Do not use elevators or lifts. Use the circulation stairs and immediately exit the building to the assembly points that are already provided outside this building. Okay, I will start this event. Good morning, Excellency, distinguished guests, the lecturer, all the ladies and gentlemen, all the participants of SAPPD webinar series season 6. First, welcome to all of you. I'm Hanafi Khalifatul Iman as today Masters of Ceremony, and it is a great honor for me to be okay, sorry for the problems. So I would like to continue. And also I would like to re-welcome all of you to this event. This webinar series, 6 webinar series of SAPPD, School of Architecture, Planning and Policy Development, session 6, with the main theme, Sustainable Development in Built Environment, with the artificial intelligence base and big data analytics for urban planning and design. In this seminar also, we will have some great speakers and discussions. Before we proceed to idea, we would like to express our sincere gratitude to Ibu Professor Dr. Sri Mariati as the Dean of School Architecture, Planning and Policy Development, Bapak Professor Haryo Winarso as Head of Urban Planning and Design Research Group, SAPPD ITB. And also we have some speakers. For the first one, Mr. Andres Stefsuk, PhD, Associate Professor in Urban Science and Planning, MIT. Ibu Safia Moore, Senior Planner, Integrated Design and Planning, ARUP, Indonesia. Bapak Ridwan Sutriyadi, PhD, Associate Professor in Urban and Regional Planning, ITB. And also Ibu Dr. Eng Maya Safira, Lecturer in Urban and Regional Planning, ITB. And for the discussions, there will be two discussants, which are Bapak Ibnu Syabri, PhD, Associate Professor in Urban and Regional Planning, ITB. Ibu Zahratu Sabrina, PhD, Lecturer in Spatial Data Science, King College, London. And also for all the participants, all lecturers, and all students who already come to this room. And also I would like to give you some review for the agenda. So this webinar session will be start with opening speech from Dean of SAPPD, followed by introduction from Urban Planning and Design Research Group, SAPPD. Then we will move to the main agenda, which will be given by the speakers and followed by discussion sessions led by the discussion and moderators. And also the Q&A session, wrap up and closing. So for the first, before we move to our main agenda, it's time to us to hear the welcoming speech from Ibu Professor Sri Mariati, Dean of School Architecture, Planning and Policy Development. For Ibu Dr. Sri Mariati, please deliver your speech.
Distinguished all speaker, discussant, moderator, and participant all over the world. Good morning, good afternoon, good evening, wherever you are. Assalamualaikum, warmest greeting from Indonesia. Thank you all for coming and joining us here today in the sixth session of the School of Architecture, Planning and Policy Development webinar series, Sustainable Development in Built Environment. The topic of the webinar today is AI-based and big data analytic for urban planning and design. It is very interesting and important topic nowadays. Webinar with the theme Sustainable Development in a Built Environment are held regularly once a month as a means of discussion from experts and practitioners in the field of design, planning, and policy development. The webinar today is coordinated by the Urban Planning and Design Research Group, one of 9 research groups in our school. I would like to thank the head of the research group, Professor Haryo Winarso, and the members of the Urban Planning and Design Research Group. This webinar is supported by Massachusetts Institute of Technology, the National Urban Forum from Ministry of Public Work and Housing, Republic Indonesia, and ARUP. Thank you very much for the support for this event. We hope that our cooperation will continue to grow. In this opportunity, on behalf of Institute Teknologi Bandung, I would like to welcome the speaker, Associate Professor Andres Stefsuk from MIT, Ibu Safia Moore from ARUP, Bapak Ridwan Sutriyadi, PhD from ITB, and Ibu Maya Safira, PhD from ITB. The discussion, Bapak Ibnu Sabri, PhD from ITB, and Ibu Zahratu Sabrina, PhD from King College, London. And also the moderator, Professor Haryo Winarso. I believe our webinar today will produce insightful lesson, ideas, knowledge, information, and reflection for the urban planning and design practice and the new urban agenda. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much for Ibu Professor Dr. Sri Mariati as the Dean of School Architecture, Planning and Policy Development, who has given us the opening speech and open this webinar series. So we will move to the next agenda. The next agenda is introductions of Urban Planning and Design Research Group, which will be delivered by Bapak Professor Haryo Winarso, and as a moderator for today's agenda. First, I would like to introduce Bapak Professor Haryo Winarso. Bapak Professor Haryo Winarso as a head of Urban Planning and Design Research Group in SAPPD ITB. Bapak Haryo got his bachelor degree from Universitas Gajah Mada, Yogyakarta, and then continue his master engineering degree in Asian Institute of Technology, Bangkok, Thailand, and also pursued his PhD program, PhD from the University College London, London, England. His research interest is in land and housing development, peri-urban and inner city development, mega project, and also Bapak Professor Haryo Winarso having top publication including Residential Land Development in Jabotabek, Indonesia, Triggering Economic Crisis, published in 2002 in Habitat International, and then Peri-Urban Transformation in the Jakarta Metropolitan Area, published in 2015, published to the Habitat International, and then Urban Dualism in Jakarta Metropolitan Area in Megacities, published in 2011, and then Private Residential Developers and Spatial Structure of Jabotabek in Urban Growth and Development in Asia, published in 2019. For the next agenda, please welcome Bapak Professor Haryo Winarso. Please give the presentations.
Yes. Can everybody hear me? Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning to all participants. Good morning to the participant in Indonesia and good evening to the participant from US. And thank you for participating in this today's webinar. First, I would like to thank the National Urban Forum and the Ministry of Public Works and Housing, the MIT and the ARU for supporting today's seminar. Let me give you a brief overview of the Urban Planning and Design Research Group at the School of Architecture, Planning and Policy Development at the Institute of Technology Bandung. UPDRG is a research group that focuses on the academic study of urban planning and design, as well as its application in real-world setting. The group is interested in fostering innovative policy, planning and management responses to the economic, social, and environmental growth of cities and regions in Indonesia. It also wants to comprehend rapid urbanization and promote humane and sustainable form of urban development. Today, we will discuss two transformational technology, transforming urban planning and design landscape, artificial intelligence, AI, and big data analytics. This cutting-edge technology have the potential to transform the way we design, build, and sustain cities for better and more inclusive future. Artificial intelligence is the driving force behind the creation of smart cities, providing planners and decision makers with new insight and predictive capabilities. By using power of AI, urban planning become more efficient, cost-effective, and suit to the specific demands of each community. AI system can analyze massive volume of data from numerous sources such as citizen input, sensor networks, and social media to better understand how people interact with their urban environment. This valuable data can be used to guide decisions about transport system, infrastructure development, and resource allocation, resulting in greater mobility, reduced congestion, and improved public services. Furthermore, AI-powered simulation and modeling enable planners to visualize many situations and their potential results. This foresight enables us to make informed decisions that optimize resource utilization, energy usage, and environmental sustainability. Let's have a look at big data. In today's environment, data is plentiful resources, and harnessing its potential is critical for good urban planning and design. Big data analytics allow us to acquire, process, and analyze large data sets, revealing previously undiscovered patterns and trends. We can acquire thorough pictures of urban dynamics, such as population trends, traffic patterns, and land use changes. By utilizing this abundance data, with this knowledge, we can respond proactively to developing urban challenges and design cities that are adaptable and resilient. Furthermore, big data analytics promotes a citizen-centric approach to urban development. We can ensure that our city represents the aspiration and needs of the people who live in them by involving the community through data-driven decision-making. Consider a city where public services are optimized using real-time data. Traffic flows smoothly, energy usage is low, and green spaces thrive. AI and big data analytics hold the key to unlocking this vision of the future. However, as we embrace these powerful tools, we must keep ethical consideration, privacy concerns, and inclusion in mind. We must ensure that the benefit of AI and big data analytics are available to all members of society, regardless of their background and circumstances. To summarize, AI and big data analytics are more than just buzzwords. They are the driving force behind a new era of urban planning and architecture. By incorporating these technologies into cities, we can build lively, sustainable, and intelligent urban areas that improve the well-being and quality of life for everybody. Let's join forces as a visionary, urban planner, and citizen to embrace the possibilities of AI and big data analytics. By doing so, we may create cities that genuinely mirror our community's goals and aspiration. With the above background in mind, today, the Urban Planning and Design Research Group invited 3 speakers and 2 discussants to discuss AI, big data analytics for urban planning and design. The first speaker is Associate Professor Andres SAPPK from MIT. Andres is Associate Professor of Urban Science and Planning at the Department of Urban Studies and Planning, head of the City Design and Development Group, and he also leads the City Forum Lab. His research focuses on public qualities of cities and on making urban environment more walkable, sustainable, and equitable, bridging the fields of urban design, spatial analytics, and mobility research. The second speaker, Associate Professor Ridwan Sutriyadi from ITB. Ridwan from the Urban Planning and Design Research Group. He is now the Director for ITB Non-Regular Education, who oversees the management of continuing education and the Engineer Professional Study Program. He was chairperson of the undergraduate program of Urban and Regional Planning. His research interest is on smart sustainable cities. He has published several books on the topic of smart cities and urban planning in the 20th century. The third speaker is Dr. Eng Maya Safira, also from the Urban Planning and Design Research Group. Her research interest is in urban planning and urban transportation engineering. The final speaker, with Safia Moore, is from Arup. I have to apologize for typological error in writing your name, Safia. It should be Safia with H, S-A-F-I-A-H, not Safia like what we have in the poster. Safia is an urban planner currently leading in the planning offering at Arup in Indonesia. Safia applies her skill in city system thinking, participatory planning, and sustainability and resilience to a broad range of projects. Her role in project is to explore the question, how does the city works and who is the city for? to collaborate with clients and communities to design to the best meet the needs of citizens. A recent project include managing the large-scale master planning project for the government of Indonesia, integrated land use and transport strategies, urban renewal strategies across Sydney, digital strategies and vision strategies for cultural institutions such as the State Library of New South Wales and Walls Bay art precincts. After the 4 speakers, we will have 2 discussions. The first discussion is Associate Professor Ibnu Sabri. He's from Regional and City Infrastructure System Research Group. His interest is research interest is on the spatial economic and what Pak Ipeng? Spatial analysis. The second discussion is Zahratu Sabrina, PhD from King College London. Zahra research interests draw within the implementation of quantitative methods on platform urbanism, urban tourism, and housing topics. Her current works have been focusing on the possible disruption from the rapid adaptation of digital platform in cities using various spatial analysis methods and predictive modeling. Well, now allow me to lay out the ground rules for the webinar before we get started with our discussion. There will be 3 sessions. Each speaker will have 15 minutes in the first session to deliver their presentation. I then will welcome the discussion in the second session to offer their thoughts on the 3 prior presentations. Each discussion will have 10 minutes to do so. All attendees have the opportunity to ask questions during the final session. Each presenter can respond to the discussion comment in the final session before the question from the attendees. Yes, let me now start with the first speaker. Thank you for coming, Andres. I think it's a night there in Boston, so we have to be right on time. Otherwise, it's gonna be very late in Boston. But no, time is yours, Andres. Please.
Thank you, Haryo, and thank you for hosting us. It's a pleasure to be back virtually at ITB and in Indonesia. And I do have to apologize in advance that I'm probably not going to be able to stay till the very end because of the time difference here. So I would very much like to, and we just have early morning lecture tomorrow morning as well. So I'll try to balance both of these. Let me see if I can get my screen share started. Can you see my screen okay?
Yes, it's clear.
Okay, great. So I'd like to start off by just saying that data computation and now recently large language models like ChatGPT and others seem to be creeping into all domains of MIT, including urban planning. And indeed, we see their use in transportation, in land use planning, in urban analytics, city design, and many other sectors of planning. And in that time, I believe it's increasingly important, and even perhaps more important than before, to have a sense of direction. What kinds of cities do urban planners want to achieve with this new technological world of possibility? In my own research, it has become quite clear that in our group, we focus the use of such technologies onto planning more sustainable, healthy, and equitable cities. But this is by no means a given. And in fact, without having a clear sense of direction, I am frankly concerned that the use of these technologies can very well be co-opted by other interests and lead us to the kinds of cities that are not perhaps the ones that planners seek to achieve. So let me just give you a quick run through of the kinds of projects we are currently working on where we do make good use of urban analytics and indeed AI, but where we try to keep the focus on achieving those sustainable, healthy, and equitable cities. Most of the work around MIT these days that seeks to address issues of sustainability, and in particular in the world of transportation and mobility, almost automatically drifts to the response to decarbonizing urban mobility being electric vehicles, automated vehicles, and transport network companies like Lyft, Uber, Grab, etc. And I have been fairly critical of this approach because I think when we seek to decarbonize any particular urban sector, we have to look at the same time what other urban issues we might be able to address with the solutions we propose. For instance, decarbonizing buildings at the same time as decarbonizing mobility, addressing issues of equity that may be historically embedded, addressing issues of public health, economic development, social interactions, etc. So it's for this reason that I've come to believe that we really need this sense of focus. Where do we want to drive these technologies? What kinds of urban environments do we seek to create with them? If we lose sight of this focus, I'm concerned we can very well be taken off track and in fact lead to the environments that we seek to avoid. So in my research group, we very much are interested in planning walkable, transit-oriented built environments. And I'm going to try to walk you through 4 examples of the research we're currently engaged in. First, on the behavioral side, how do the environmental characteristics of streets affect where people prefer to walk? Second, how can we map pedestrian infrastructure in cities? It's a problem and it's a question that is yet to be resolved. Most cities, in fact, do not have infrastructure maps that represent the pedestrian realm in any accurate ways. Third, how can we identify the most critical links in pedestrian infrastructure for improvement or investment? And last, how could we use such models to develop what we now refer to as pedestrian impact assessments? How can we forecast ex ante or in advance how urban interventions and changes in infrastructure will affect pedestrian mobility in particular? So let me start off with the first. How do environmental characteristics affect people's behavior on foot, where they prefer to walk? This realm of research is primarily known as pedestrian route choice literature, and it indeed makes quite some good use of large analytic models. Think of a situation where you want to walk from an origin to a destination in a city. Very often in such instances, you have many routes available to you. And the question is, which route do you choose and why? In this diagram here, I've chosen a highly connected street network from New York, where just a few blocks from St. Patrick's Cathedral to Carnegie Hall, which is only about a 5-minute walk, you have 84 route options that are all exactly the same length. So pedestrians inevitably must make a choice. And the theory goes that these choices are affected by environmental qualities of the routes that differ on the different routes. Some routes have wider sidewalks, some narrower, some have more traffic, some less, some have more enclosure or sense of enclosure on the streets, more tree cover, more ground floor amenities, and so forth. So using analytic models, we can test how such features actually affect observed route choices by pedestrians whose routes we have data on. In this research, we have used large data sets of anonymous GPS traces from activity-based app users. We've done this work in a couple of different cities. I'm going to show some results from San Francisco in particular. The data that we had for this studies included several 100,000 GPS traces of pedestrians walking in San Francisco. And we narrowed it down to a usable data set of routes. We couldn't use all routes because many of these trajectories were simply short straight lines where there was no route choice really available. So we had to narrow the data set to find routes that actually included choice. We had to construct route alternatives to do this. So the red line here represents the actual route somebody walked, and the blue lines represent route alternatives they could very well have walked but did not choose to. And then we associate both the actual route and the alternatives with a whole set of different route attributes, such as their sidewalk qualities, ground floor amenities, traffic levels, levels of greenery, and so forth. So using statistical models, we can then detect how any one of these attributes actually affected the choice probability of the route people ended up with. For instance, the negative coefficients here in the fourth model show factors that had a negative impact. So as expected, we expect longer routes to be less likely, therefore a negative effect on length. Same for turns, same for elevation gains. These are attributes that people tend to avoid. But for instance, ground floor amenities, these are ground-facing retail businesses, service or cultural amenities that face the sidewalk are something that people do like to pass, and therefore we see a positive effect, and that's also highly statistically significant. So a very interesting side effect of these route choice models is that we can take coefficient ratios with respect to some control coefficient like distance, and therefore translate the effects of one quality to the equivalence of distance. So for instance, we can find from this analysis that one extra turn along the route in San Francisco is perceived as equivalent to the walk feeling like 62 meters longer. Walking uphill, every meter of elevation gain is perceived as equivalent to the walk feeling as if it were 3.8 meters longer. And passing every amenity or an extra amenity makes the walk actually feel shorter. Passing each extra amenity makes the walk feel 1.8 meters shorter, and so forth. So this is the way in which we can translate route choice attributes to distance equivalence or willingness to walk coefficients. And this is important because it allows us to incorporate these effects into predictive models to forecast how people will actually behave in the presence of different environmental qualities. And it also allows us to have policy relevant results. So for instance, here is an example where we have traced 3 types of walk sheds and bike sheds around transit stations in the Boston area. The largest polygons in the kind of bluish green are bike sheds that are 1.5 miles outside of each station. And the light green overlays on top of them are perceived 1.5 mile bike sheds. So they're not just geometric distance from the stations, but they take into account the characteristics of the streets that bicyclists face, how much traffic there is, whether you have to go counter traffic, whether you have to bike uphill, how many turns you take, and so forth. And the same goes for pedestrians. The red polygons show objective or geometric half-mile walk sheds around each station, and the overlay in orange shows the same half-mile in the perceived distance that takes into account street attributes. So by doing this, we can actually delineate more accurate walk sheds that describe station catchments for affordable housing provision, or predict more accurately from which locations people are actually likely to walk to stations. So I want to transition quickly to the second area of research. As I mentioned, many cities lack sidewalk data. A lot of the research that's presumably addressing pedestrians has to rely on road centerline data that is generally available because the world's roads have been mapped throughout the last 25 years. Sidewalk mapping, however, is critical if we want to understand accessibility to opportunities, to transit, to destinations from a pedestrian perspective accurately, not assuming that people can behave like cars and can cross streets where cars can actually do that. Sidewalk mapping has been tested and tried in various different ways, such as mapping them manually over aerial imagery, buffering roads, tracking pedestrians with GPS, and so forth. In this research, we have used and developed an automatic sidewalk detection system using machine learning and computer vision based on aerial imagery of cities. The system is called Tile2Net. It's in fact open source and available on GitHub, and you're welcome to check it out and perhaps even use in different parts of Indonesia, even though it has not been trained on the aerial imagery, particularly from Indonesia. As a side note, that's a project we do seek to embark on. Right now, the system is trained on mostly US cities, but it performs quite well even in some international cases. The system works as follows. we feed in ortho-rectified aerial tiles, which are basically just satellite image tiles like you have in Google Maps. They have to be at a certain resolution, at a sub-meter resolution, in fact. The model then will detect different classes of infrastructure elements. It will detect roads, but also sidewalks, crosswalks, and footpaths that are in parks. It will then convert them to polygons, and then will convert the polygons to networks that can be used for routing. In order to train this system, we had to prepare thousands of images from planimetric GIS data that was available in some cities in the US, where we knew where sidewalks were, crosswalks were, where footpaths were, and then those were further and manually corrected to create annotation classes that can be used to train the model. So for instance, in the middle, you see the raw data that was available from the cities. And then on the right-hand side, you see the manually corrected training data that we finally trained the model on. Once the model is trained, it can be used to process aerial imagery, recognize sidewalk infrastructure, crosswalk infrastructure, and footpaths in parks and inside blocks, and turn that into networks. And then through automatic cleaning processes, ensure that these networks are close to routable. It usually does require some additional manual correction work on top of it. This is an example of its application in parts of Boston. And here are some instances applied in New York and Washington, DC. The model performs fairly well, even if images that are fed in are secluded or include shadow or tree cover, because it is trained on planimetric data. That means that the training data knew that sidewalks do continue under these trees and shadows, and therefore the predictive model is able to normally also overcome such obstructions. We think this is an important stream of work because it opens up a scalable approach to actually mapping sidewalk and pedestrian infrastructure in cities globally, and could lead to all sorts of different applications. Now, I want to finish by showing two examples of application once we do have certain street network data or sidewalk network data to use. This third project shows how we can use predictive models to detect most important pedestrian links for improvement or prioritization in infrastructure investment. And this actually comes from Indonesia. This is work we did in Surabaya as part of planning for the Surabaya light rail corridor to go through the city center, financed by the World Bank. During Tri Risma's tenure as mayor of Surabaya, it was an important flagship project to propose a light rail throughout the city center. The trajectory had already been laid out with stations. And as part of many other aspects of the TOD work, we analyzed how people would be able to get to the stations and which streets are most critical for giving people access to the future stations.
Andres, I'm sorry, 3 more minutes, please.
Sure. So through this work, we used network analysis tools developed in our research group, the urban network analysis tools, which are available both as a plugin for Rhino 3D, and most recently, actually this summer, coming out as a Python library as well. And we were able to route trips from different census blocks and residential areas around the proposed light rail corridors, analyze which streets are likely going to have most foot traffic, and then filter out just those routes that have over certain critical levels of use, in our case, 5,000 pedestrians per day, which ended up delivering a pretty short list of segments, which could then be observed and examined in person on sites. Some of these paths were in great conditions, like for instance, this Kampung Lane here, which is recently paved, has great drainage, lighting, active retail edges and so forth. And some of them were problematic. Some streets would routinely flood, and those were the ones that really needed the most investment. So to finish, I'm going to show a project we prepared in Melbourne, Australia, where we developed not just a model to predict one type of pedestrian journey to train stations, but in fact a model that estimates pedestrian journeys on all city streets for all important trip types during peak periods. This model was prepared to do what we call pedestrian impact assessment. So as many of you know, when cities build large infrastructure or building projects, oftentimes they have to do traffic impact studies. And these traffic impact studies usually examine how the proposed projects will change traffic on city streets. And if this is forecasted to cause congestion, then developers may be obliged to financially support street widening for cars, extra turning lanes, more parking, signal readjustment, and so forth. So in this model, we actually did a study of a very similar concept for pedestrians, where we calibrated a model of foot traffic on the city streets of Melbourne. We calibrated that model based on actual foot traffic counts from pedestrian sensors. These are infrared sensors at around 90 locations presently throughout the city center. We forecasted or estimated trips between many different origin-destination pairs for pedestrians, and then using statistical fitting models and machine learning, actually, we were able to detect which of these trip types actually mattered and how much during different time periods, and then yielded foot traffic estimates for all streets in the city center. So even though the model was only calibrated at the locations where the sensors were available, these orange dots on this map here, this map shows estimated foot traffic during the morning peak period from 8 to 9 a.m. on all city center streets, not just the ones where the model was calibrated. And that's the power of doing such models. We can actually arrive at the sort of citywide census of foot traffic for different time periods. And we know that this model fit well. We could test using the standard vector regression machine learning models that the fitting R-squared value is over 90% on all periods, at AM period, lunch period, and PM period. And why is it useful? Because just like every city, there's constant development change. So we could test how different land use changes implemented throughout the city center in a 1-year period, shown on this map. So the blue buildings here are all buildings where there's a increase in jobs or residents in a 1-year period. And the red buildings are those where there was a decrease in jobs or residents in a 1-year period. We could basically estimate how these land use changes, the whole suite of different projects that were built or changed in a 1-year cycle in Melbourne, would change foot traffic, which is what this final map here shows. This is the forecasted change in foot traffic after these projects. And because we had actually longitudinal pedestrian count data from the census, we were able to check how good these forecasts are. And we could see that the forecast accuracy was around 78% in the morning peak period, 82% during lunch, and 74% in the evening peak period. So I just want to finish that by saying that these sorts of analysis can help cities request developers to do pedestrian impact assessment instead or in addition to traffic impact assessment. And instead of road widening, signal readjustment for cars, more parking, etc., to accommodate the extra traffic, why not ask developers to pay for better crossings, better public spaces, safer crossings for everyone, and generally a better pedestrian realm, because that's ultimately where cities want to go. Shift the modal share away from the 20th century traffic legacy, more towards walking, cycling, and public transit use. So thank you very much. And I look forward to the other presentations.
Thank you, Andres. I appreciate very much your very thoughtful presentation based on your research experience. Well, because Andres will have to leave early, I will open 2 or 3 questions if there are, and I've write it down in chat. If you have, please write it down in the chat box. No questions set now. Oh, dari Unisba, mana ya? Oh, can you write it for me, please? Mr. Andres is.
Yeah.
AI and big data technologies gather and analyze vast amounts of personal and sensitive information. How can cities strike a balance between harnessing this data for urban development while safeguarding individual privacy rights and ensuring ethical use? Please, perhaps you can answer this. Yeah.
Yeah, this is a question that comes up all the time, and I think it's a very important one. I would like to start the answer by saying that historically, the kind of information that urban planners have collected about cities tends to be overwhelmingly static. That means describing the built environment, the buildings, the land uses, the landscapes, the infrastructure. And only in the last 25 years or so has the dynamic information about how people actually behave in cities, whether it's about their mobility or preferences or other choices they make in cities, become available as data. On the one hand, that's very exciting because it allows us to start developing an understanding of how people actually behave in different built environments and how that varies by the kind of person that we study. But the way, at least in my research group, we strike that balance is that we're very much careful on not building any models or analyzing any one in particular, or even seeking data from any person beyond any comfortable privacy limits. So for instance, the route choice data that we had from GPS traces in San Francisco was all mapped to the starting street intersection and ending street intersection, not to anybody's home address. And we had no idea who these people are. We had no personalizable information whatsoever. It was only an anonymous trace that somebody walked, right? So in fact, one of the ongoing conversations that is very important in this, that I advocate for, is that cities, when now cities and states collect such information themselves as part of travel surveys, most large cities that conduct travel surveys, in fact, now use GPS technology, right? They ask people, how did you spend your day? How did you travel? And researchers can use that. Instead of needing to know who that person is, what is, I think, a good balance is to publicize the high-level demographic characteristics of the users. Was the person male or female? Was the person young, middle-aged, or old? Was the person high or low income? These high-level categories are sufficient for research to understand how human behavior and preference vary by demographic groups, which is very important for planning, because if planners come in and say a planning solution is an average for everybody, it can very well miss the mark and fail to deliver an environment that actually caters to the behavioral needs of individual groups of people. So for instance, as I showed in this catchment area analysis where we had these behavioral catchments, right? They may differ for men and women. And if women have different preferences in route choice and are uncomfortable walking certain streets, then we cannot delineate them in accurate ways or build, for instance, affordable housing or other amenities in areas that we think may feel like a 10-minute walk to the station. We may actually be wrong in that regard. And so it's important, I think, for research purposes to at least be able to understand how behavior varies by demographic groups, and we generally do not need to go down to any individual identifiable data.
Thank you. Thank you very much, Andres. I think we have to proceed with the second speaker now. Thank you for the experience and research, and this is very thoughtful presentation that we can learn from MIT. Well, next is Pak Ridwan Sutriyadi. You have also 15 minutes for presentation, and I will remind you 2 minutes before the time's running out. Please, Pak Ridwan. So we actually have 4 presentations. The third presentation is more based on the research, and the last presentation, which is very important, is actually is the application, because Safia will give her experience in using AI and big data. Please, Pak Ridwan.
Thank you. Terima kasih Pak Haryo Winarso, Professor Haryo Winarso, and distinguished guests and participants here. Well, I would like to share my presentation. Maybe I will do it in a very fast way because of too many slides. As you know, the problems in planning concluded by what happens in the US can be shown in three categories. The first one is related with the interplay of ideas, and second one, how the common persists over time, and the third one, the concept of change. If we are looking at the literature review, as we know that planning comes from the two main, biar bisa di itu. Comes from two theory. The first one is information theory, which focuses on communication within system. The second one is cybernetics, which is focuses on control of systems. So that's why then planners have a significant role in promoting or managing or govern the public sector, since it has to deal with natural subsystem, economic subsystem, social subsystem, and then the important one is the scientific context. Other things we would like to show is the publication of mine till 2019. It is show that what has been important in planning concern with smart city, technopolis, and then the sustainability in Indonesia is the four component. The first one is the role of planning. The second one is the urban growth. The third one is the sustainable development, and of course, how to understand all of the things in terms of urban problems. Other things we would like to show is about the Indonesian urban development illustration. We can show the metropolitan, large-size cities until the rural area in the national border area, identification of problems, and then the identification of urban development within the region of Indonesia. And then there are 14 problems of urban development in Indonesia. Other things that I would like to share is that there are development issues related with urban development in Indonesia. The third one is related with the unpredicted values. The second one related with the unpredicted environment. The third one is unpredicted decision-making process. For instance, the first one is the obligation of the city to provide 30% green open space. How to translate this in the level of the city and local. The second one, for instance, the arrangement of river boundary line. How to translate this in the level of local and city. The third one, for instance, the problem is Northern Bandung area, some of which are protected area and other are prestigious areas for housing, which is related with the decision-making process in a national level, provincial and local. So that's why for unpredicted values, we have the sufficient or appropriate approach, what guidelines are needed, what clear development goals. For unpredicted environment, we have to promote research, survey, analysis, and estimate what to do, need more information. The third one, what facilitation is required, and then more conducive coordination is needed. So that's why this is the role of urban planner. We have to concern with three things: coordination, synergy, and synchronization. The third one is related with the landscape of bibliometric analysis of the with the keywords of urban analytics, urban data anal, or urban informatics, geospatial analytic, or urban computer. So I can show in a very fast way. For instance, in the last from 2000 till 2023, there are at least 3,000 articles related with the urban planning and data analytic. Some of those are related with the intelligence and lecture, SM International Conference, topmost 20 most productive countries. Of course, the third highest is United States, China, and Australia, while Singapore is in the 10th rank. Top 30 productive institutions such as Queensland's University of Technology, because they promote journals and books. Sun Yat-sen University of Sun Yat-sen University, University of Oulu, Wuhan University, University of California. Other things is the writer, the author of related topics on AI. Hello? Yeah. This the bibliometric coupling between countries. It is shown that United States, Australia, and China, the domination of the research, while the keywords in the research, which is related with the first one, urban computing, geographic information system, urban planning, spatial analysis, human data mining, and smart city decision making, ubiquitous computing, and then urban informatics. This the concern about three keywords, 30 keywords in a certain time period, such as big data, while in 2023, ubiquitous computing and then spatial analytics become more popular. Here are the word cloud of top 50 keywords. The biggest one is urban computing, and then followed by geographic information system. So glad to read about urban planning right now is appear bigger than smart city, and also the consideration about human and spatial analysis. Here are the co-occurrent network keywords. We can show that there are at least 4 polarization. The first one is urban planning, the second one urban computing in green one, and then urban informatics, and then spatial analysis, and also the consideration or the focus research on human. Other things, this is the thematic evolution of urban analytics studies from 2000 to 2010, and then 2011 to 2019, and 2020 to 2023. It showed that the concern to the human, urban planning, and then spatial analysis and urban computing become the 4 most significant one. Here are the study thematic map of urban analytics from 2000 to 2023. In the first, the green one, the big one is the urban computing, and then data mining, smart city, ubiquitous computing, and then urban informatics. Other things that related with the study thematics during 2000-2010, spatial analytic, geographic information system, and then multi-user virtual environment, 3D data, just like a few days ago, we have in ITB in AI Center, because we have AI Center, we initiate the cooperation with South Korea for monitoring video. Study thematic map of urban analytics from 2011 to 2019. 3 pillar: spatial analysis, human, spatio-temporal analysis, risk assessment, cluster analysis. The second one, urban computing, urban informatics, ubiquitous computing, and then data mining and big data. The things is related with the geographic information system, urban planning, decision making, urban simulation, and urban growth. This one is for the last 3 years. The big one is urban computing, forecasting, urban transportation, just like maybe later Bu Maya would like to show the cases, deep learning, and data mining. The collaboration network, it shows that US, China, and United Kingdom, Germany, and Italy are the 5 countries with the highest number of collaboration related to research in urban analytic area. There's other things, information about the interinstitutional collaboration, Syrian University, and then MIT also available here. This is what have been done by collaboration between IAP, SAPPK, main, EY, Cisco. We promote next generation city using sentiment analysis. Other things, here are my research roadmap related with the smart sustainable city. for the last 13 years. The first term is the cellular technology for urban planning. The second one related with ICT and urban planning. The third one, resilient cities. The fourth term is livable cities. The fifth one related with technopolis research. The sixth one related with the urban transformation in the 21st century. The seventh one related with the integration of TEM cities to urban development. The eighth term is the urban planning and development towards digital transformation era. So to continue those terms, I also conduct some publication which is related with some keywords. For instance, for the first and second term, I conclude that there are some keywords related with ICT, work from home, work from office, regulation, communication channel, and then the second related with the green infrastructure communication pattern, which is raised with the keywords land conversion, land use control, communication channel, public awareness, openness in terms of policy. The third one, urban energy research, raised some keywords: efficiency, new and renewable energy, lifestyle in the urban area, regulation in city level, related with the urban village research, assets, the transformation or reformation of the theme of assets, urban history, location of factor, life cycle, variety of business, value access, technopolis in metropolitan area. The keywords here are knowledge, stakeholder, preparedness, branding, rooted innovation, books of planning in the 21st century, weak problems, planning support system, innovation, technology, and transformation. The last two is the research on TEM city, identity, TEM's potential, social system, integration of planning system. And the last one related with the planning anticipation, transformation, process, policy, breakthrough, and priorities. I didn't mention about the existing research on 2003 related with the post-mining city in IKN, maybe later. So so I propose the body of knowledge of the role of urban analytics for the planner, which is consists of, at the urban planning, we have to concern with the main idea about how to analyze or to deal with structure and pattern in a level of city, which concern with at least 5 components: policy, infrastructure, neighborhood level, building codes, and regulation. Other things shows from the bibliometrics, there are some kind of first layer of key important things such as urban computing, decision-making, urban computing, decision-making process, spatial analysis. The second layer is related with the stakeholders, concern, common goals. And the last one, this is the very important one, is the scientific context, especially for the public concern. This is important to make progress to achieve sustainable cities by considering those laws and regulations in Indonesia, from the national planning system law until the spatial planning delivery. Thank you, Pak Haryo.
Thank you, Pak Ridwan. You still have 1 minute actually, but anyway, thank you very much for your very interesting presentation. We learned a lot from your presentation. Enlightening. I believe that there is a lot to be discussed later. At the first presentation, learning about the research on based on the AI and big data analysis, and the second part, Ridwan, showing the trend of research in the world based on the AI and big data analysis. Now we will have Dr. Maya Savira, who I believe will also present her research on transportation, if I'm not mistaken, based on the AI and big data. Please, Maya, you have 15 minutes, and I will remind you 2 minutes before end. Please.
Okay, thank you very much, Professor Haryo, for the introduction. So, good morning, everyone. It's really a great honor to be here. Actually, I'm really nervous now because it's been a while since I give a presentation in English. So maybe if there's some mistake, I should apologize in advance. So thank you so much for the opportunity. I would like to share our ongoing research. So our title, I call it as an appetizing effect. It's based on our personal interest in the food, actually. So for all of you who like to order some kind of online food delivery, so this is the research about that. We try to explore the impact of online transportation that provide the online food delivery services using the emerging data sets and also some kind of a new approach in the collecting of data set and also the analysis and visualization. So maybe first of all, I would like to introduce myself a bit. So I'm a new lecturer in the urban and regional planning in ITB. My background is from urban planning. I pursue my bachelor and master degree for ITB and continue my PhD in Hiroshima University under the Urban and Transportation Engineering Lab. So I try to focus on urban analytics, which in this year, we just start our research in March to explore the impact of online food delivery services to the urban form and the transportation behavior with the case study of Bandung, Indonesia. So different with the Professor Andres have been presented, in this case, maybe the scale is more macro and more related to the transportation. So first, I want to introduce why we call it as an appetizing. So maybe first, there's some application or just term that we called it as a MSTP, multi-service transport platform, that I want to introduce. This term may be not familiar yet for all of you, but it's kind of the online-based platform that provide multi-services for our daily life, not only the ride hailing, as you know, maybe like the Uber or the Lyft in the America. In Indonesia, we have kind of Gojek and Grab who provide the online transportation, ride hailing, and also the daily services as the online food delivery and also the daily necessities. So the MSTP allowing people to virtually access the services in other area without travel. So it kind of improving the accessibility and minimizing the cost for the user, including the travel cost, travel time, and also energy. With their main fleets is on motorbike. Actually, like Gojek or Grab, they also have the car as their main fleet. But in this case, because we focus on the food delivery services, we focus on their motorbike fleets. Okay. Just for the short introduction of this MSTP, so there are some components, important components that you need to know first, especially for the context of food delivery. There's a user, which is us as the user of the application, and the partner merchant, which is the food merchant who have a contract or the partnership with the MSTP, and also the driver, which is as the main fleets to deliver the food to the customer. Actually, the relationship between the component, it's not that simple as we saw before. So there's some effect that happening in between the component and also among the component itself. So there's some cross-site network effects, such as the distribution of the information flow, experience, and curiosity, and also we have some same side effect, which is the information, decision, influence from other will affect their own decision for the user or also for the merchant. And both our decision also affecting the decision for driver to wait or to looking around the area. So I will explain this later on. In this opportunity, actually we have a lot of ongoing research happen nowadays, but due to the time limitation, maybe I will focus on two sides, which is from the merchant side and also the driver side. So for the first part, the question is how the impact of MSTP to the distribution of urban facility, which is in this case is the food merchant. First, we want to know how is the distribution nowadays with the presence of MSTP in their operation system, and also why there were they. We try to analyze the factor that affecting they agglomerated or separate. The case study is Bandung in our city. It's a capital of West Java, the second highest number of user and merchant of online food delivery behind Jakarta, DKI Jakarta, our capital. And it also very dense with 2.67 million inhabited. And it also famous as a destination for culinary tour in West Java. So using some Google Scrap methods, we found that there's 7,044 food merchant in Bandung, which 79% or 5,087 of them are online food merchant, which is the existing food merchant with a partner of MSTP. Based on this distribution, we try to analyze how its distribution, not using the analysis of density, but we are using the agglomeration index. Yeah, why we're using the agglomeration index? It's we want to compare how the scale between the how the index between each scale of this one is the sub-district in Bandung. So we have 151 sub-district in Bandung, and we found out that the average of agglomeration index in Bandung is 0.8, which it means equal to 1, where the commercial facility or the food merchant and the public facility is equally distributed. However, it maybe make some another question for all of you, where if we see the actual distribution, it might seek centered in the central area, but if we calculate with the agglomeration index, it's not that like that, because we have a large number of public facility also located in the central area. So somehow the number and also the distance between the facility, it's equal across Bandung city. Yeah, so this is the distribution. However, we also have conduct the other agglomeration index study 1 year ago in Jakarta and also this year in Medan. We found a different pattern between the three big cities in here. Like if we see in the biggest user and number of merchant in Indonesia, which is DKI Jakarta, the left side, it shows that there's some agglomeration happen for the online food merchant in the center and the peripheral area, which is it's very different with the Bandung city and also Medan city, which is the second and the third largest user of online food merchant, which is more spread across the city. So we also still validate our findings, but we also try to analyze what factor affecting their decision to be agglomerated or spread across the city. So based on our literature review, we included 6 factors by using the grid analysis and geographic weighted regression. We found out that there's 5 independent variables that significantly affect their decision, including the accessibility, the population, number of population, which is also related to the potential demand of the food merchant itself, the road network density, and also the presence of other facility around the food facility. However, our finding is not, the model is not good yet. So we are still improving the variables and the factors that we will include in our models. So I also want to introduce the second part. It's about the travel behavior of the drivers. We try to explore how the impact of MSTP on the drivers' schedules and also the location of their idle time, where they prefer to stay while waiting for the orders or while looking for the passengers. So I think there's still less or minimum research about the motorcycle taxi drivers, especially in the developing countries. We found the similar research for the car taxi in America. So we want to try to explore how their behavior, including their schedule and also their preferences. Yeah, maybe I want to introduce first. So in Indonesia, we rely on the online motorbike or motorcycle taxi driver. In the local bahasa, we call it online ojek. This is the main fleet of MSTP who drove the passenger, and also pick up the order from the merchant to the user. The problem we face nowadays is they don't have the specific base location or the specific location for waiting. Yeah. In our campus also, if we see nearby our campus, they are occupying the public space, which makes some people uncomfortable. And also the other impact that happen is traffic jam, where they waiting in the roadside or also the parking area. And the integration of other modes also caused by this problem.
Maya, 2 more minutes, please.
Okay. So maybe I will skip to the introduction. And this is the finding that we found that most of the driver have 4 peak schedules, including the morning peak, noon peak, afternoon peak, and night peak. Maybe I will show this one. So within the 24 hours, we found out that in the area with the highest number of food merchant, it's become their most important factor to choose the location to waiting or to find the customer. Where in the morning, they also feels residential is important for they to pick up the passengers, and also in the afternoon peak, they find that in the school and also the office is also important. So this very interesting, where the food merchant almost 24 hours is preferable for the driver. Yeah, we also already have the findings about how the distribution of the location for the drivers. So in Bandung, we found out that they're still agglomerated in the central area of Bandung, but for the weekday and weekends, they have some differences. So we try to make a 3D visualization using the space-time cube. We want to see the difference in the weekdays. So the weekdays mostly agglomerated in the central area, 24 hours, but for the weekend, it's more spread. So not only agglomerated in the central area, but also in the peripheral as well. Yeah. Okay. So due to the time limitation, I just want to conclude the finding for the drivers that we found that the number of transaction or the activity 24 hours, food have a highest transaction compared to the package delivery and the ride hailing. So it indicates that the users are using online MSTP for the online food delivery service more than using for the ride hailing. So because this is still the ongoing research, I just want to sum up the current findings that the digital disruption introduced by the MSTP not only brings the benefit for our daily life, but also change our urban form and travel behavior. In our short findings, we found that the MSTP driver shows different behavior pattern compared to the other public or semi-public transportation modes such as taxi. So there's also a shift in the distribution and agglomeration pattern of urban facility caused the digital disruption triggered by the presence of MSTP. And I want to say that exploring the impact of digital disruption on the transportation sector such as MSTP become crucial in urban planning as it is closely related to our daily life aspect, including the location selection, mobility patterns, and also our daily activity decision. So that's all my presentation. I want to shout out to our research member who helped me make this presentation happen, Dr. Petrus Natalifan, Hanafi, Hafian, and Azwan. Thank you very much.
Thank you. Thank you very much, Maya. This is very interesting. I think we learned a lot from this, and we can see that the first presentation also gave a example from his research, and now also his research, which I believe is very influential to the planning, urban planning and design. And now let us listen to the last but not the least speaker, which is also very important, Xavier Moore from Arup. Arup is a well-known consultant, of course. The center, what is it? The center is in London, and we have also here in Jakarta and also in Singapore. But again, Xavier is thank you for joining us in this and willing to make a presentation. I believe that you will give a very good experience of your projects. Please, you have 15 minutes, and again, I will remind you 2 minutes before time is up. Please, Xavier.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Selamat pagi, selamat malam. Thank you very much for the invitation to join this discussion and be part of the interesting speakers here today. I think I will share a little bit that is very similar considering the perspectives around smart cities and the focus on the ambitions for cities around livability and inclusive cities. And it's been really great to hear about some of the research by the other speakers to help give that kind of data and evidence behind some of the patterns that we're seeing in the city. So looking forward to sharing that with my team as well and seeing how we can apply that in practice. So share my screen and maybe if I could, if I got the right one, it just says total architecture. Is that right? Yeah. If I could start with a reflection from Arup. So this is Sir Ove Arup, our founder. He was both a philosopher and an engineer, and the topic around sustainable development as well as digital technology was very close to the way that Ove Arup established the firm. And in the 1940s, he established a key speech that still guides the firm today. And he talked about this term around total architecture, which I think very much aligns with the ideas around sustainable development, thinking about holistic considerations, about having an integrated team to think about different perspectives. So we think that having this total architecture approach really helps to improve design to more sustainable, resilient, and intelligent and robust outcomes. The other thing that Sir Ove Arup left with us is that the company is owned in trust. So that means that the profits that we earn go back into the firm. And as employees, we're able to choose how we spend some of those profits. And some of that is in research. So we have Arup University.
I'm sorry for Ibu Safia. We cannot see in your presentation slides.
Oh, let me.
Would you please?
Sure. Proper.
Please start again.
This one better?
Okay,
yeah,
we can see it now.
Thank
you so much, Ibu.
Yeah, so as I was saying, the other thing that Sir Ove Arup left with us is this ability that we were owned in trust. So we were able to invest the profits back where we want to. And one area is Arup University, where we undertake research to then expand some of the work that we're doing with clients and collaborators. I'll share 2 examples from some of the work that Arup Research has been able to explore. But first, I'd like to provide a little bit of context. And I think it's very similar to the other speakers today around thinking about smart cities. And I often go back to this quote from Cedric Price, an architect, that was thinking about this from the 1960s around the development of technology in the built environment. It's a really great question that I think we should often reflect on is if technology is the answer, what was the question? And so if we think about maybe just looking at the challenge around cars and thinking about the future of technology just from that perspective of individual mobility and trying to get from A to B, we might end up in a result that looks similar to this, which I think is similar discussions that Andreas started with. So even with electric cars, you'll still get the congestion, the autonomous cars, and even with some of the ride sharing apps also have a similar result around poor productivity, congestion, poor health outcomes, low walkability and low inclusion. So it's really important to approach technology with care and have a deliberate intention to ask the right questions and to be able to have that human element around thinking about the ambitions of our cities. So maybe in the question around thinking about the future mobility, the question might be around how might we be able to connect people to support healthy and great places that contribute to livability. And in the context of AI, I saw this recently, and I thought it was a nice reminder around the care that we need to take when we're engaging with technology. And I think Professor Harjo also highlighted this at the beginning, and it's just a short clip that I will show.
What does a typical prisoner look like? What about a lawyer, a nurse, a drug dealer? What about a fast food worker, a cleaner, a terrorist, or a CEO? These are all images created by an artificial intelligence image generator called Midjourney, which creates unique images based off of simple word prompts. These exaggerated biases that AI systems create are known as representational harms. These are harms which degrade certain social groups by reinforcing the status quo or by amplifying stereotypes.
So just a short clip, and I think it just helps to highlight that we need to be really aware of how we're approaching technology and need to think about how we reach our aspirations. This quote from Joy here around thinking about what the broader context is and thinking about how some of these technologies get fed with data that might reinforce these inequalities. So it's up to us to think more broadly about the context of how we're working with technology. And so therefore, I think context is really key. So we need to work together with technology. We know we're good at some things and machines are not good at other things, so we can work together. And it's really important to develop, I think, data-informed design and not data-driven design. So really having that context around the kind of human element and the ambitions that we're really working towards when we think about using technology. So I'll move on then to 2 examples that Arup has developed under the Arup University umbrella and some research that we've undertaken, firstly around a new tool that is called Terrain, and it's helped to enable planners and authorities to understand how land is being used and bringing together data analytics and machine learning to automate the processing of land use from satellite imagery. And I think, again, Professor Harjo's introduction highlighted that this has brought some efficiencies. So you see that there's some efficiencies in how the land has been analyzed, and it's found to be 5 times quicker than a manual approach. So for the Terrain tool, we've used satellite and aerial imagery, both from open source data, but also commercially available data to analyze different resolutions at multiple scales. And then the terrain model was used to help understand and produce space maps for different categories of typologies of land use. So this was able to help share the land use typologies across large areas and consistently globally. So we've then used this terrain tool in this piece of work that we've done called Sponge City Index. And I mean, it's a little bit of a kind of high level index, I would say, but I think useful nonetheless. So we use the terrain tool to help look at different cities and understand the percentage of blue, green, and gray infrastructure. We also got soil types and vegetation data to understand how the runoff of those cities might be impacted by the soil types, and worked out a calculation, a kind of summary calculation for each of these cities to then think about the sponginess of these cities, how they could naturally absorb rain events. And we looked at this across 7 cities and gave them each a ranking. And so the results of that look like this. So Auckland came out as #1. So across the area that we looked at, we saw that Auckland had the spongiest urban centre with about 50% of green and blue areas, and also that the soil type enabled the the water runoff to be absorbed more than some of the other cities. So that gave it its highest, the highest ranking across the Sponge City Index. And then in comparison, say, to Singapore, the data showed that it still had high green and blue coverage at 45%, but some of the soil elements didn't lend itself to the kind of sponge elements. So it came in, I think, yeah, the 3rd across our Sponge City Index. And this is a little bit of, as I said, a high level analysis and index, but useful to be able to really start that conversation about nature-based solutions. I think we found that sometimes nature-based solutions can be a little bit challenging to think about the benefits or the considerations on how you might approach acting in nature-based solutions, you needing to work across multiple government agencies, for example. So having this data readily available as a baseline for the conversation and a little bit of a ability to compare a little bit crudely across different cities has been a really useful entry point to then have those next conversations. The second example that I'll show is not so much big data, but an interesting piece of work to look a little bit more specifically about the data that we have access to from a gender lens. And this is some really interesting work undertaken by our colleagues in Australia that looked at gender and public transport network performance from the context of Melbourne. So they highlighted that different genders can have a vastly different experience in public transport, and actually the design of public transport networks can disproportionately impact different individuals based on their gender. So they looked at Melbourne and tried to answer these questions around exploring the different travel needs between genders, what existing data and analysis has been already done to think about this gender lens, what data is available, and what does the data show in terms of the difference between the travel needs between different genders. And so they highlighted these kind of 3 elements that they looked through. So these 3 key transport functions that may be different between men and women. So one was around how public transport provides access to jobs. The second was around how public transport provides access to care destinations, recognizing that in Australia, women mainly take up the support role, the unpaid support role of taking children to care or other dependents to care facilities. And then the third one was around public transport for complex trips. So this is also recognizing that there's a whole kind of context around school drop-offs and then going to work. And often women do that journey And so it was also an analysis on how public transport provides for these multiple trips. So a quick summary of some of the analysis. So highlighted that across Melbourne, that jobs are not uniformly distributed. So you could see that in the center of Melbourne, I think maybe as expected, there are more jobs, but actually those jobs are taken up more by men. So you could see the areas outside of Melbourne are taken up more by women. And so you see that different concentration around jobs that are currently taken up by men versus women. And that also can map to the current public transport network. Of course, the public transport currently is designed to all kind of come into the center of Melbourne. So therefore it's serviced more efficiently. So currently there's a disparity between how women may be able to access some of these jobs outside in the periphery of the center. The next element was trying to understand access to care destinations. So the care destinations included things like schools.
Excuse me, Sophia, you have 2 minutes more.
Thank you.
2 more minutes, please.
Access to school, childcare, sports, and other activities. And it showed that the public transport network is only half effective in providing access to these care destinations rather than jobs. So if we were trying to get to these care destinations within only 30 minutes in the interpeak, only 1.1% of those total care destinations were accessible. And when you go to 45 minutes during a peak, only 4.1 of those care destinations were accessible. So it's highlighting that the public transport network hasn't been designed for these types of trips that are actually mainly taken by women. And then the last lens that they looked at was this element of complex trips. So they analyzed this scenario of going to school drop-off and then continuing on to work. And so they analyzed, once you get to school, then how has the public transport enabled efficient access to work from those schools. So again, it highlighted that the total jobs accessible within 45 minutes during the peak period is only 182,000. And then when you get to the morning peak period, this school drop-off window, there's a reduction in the jobs accessible during that equivalent time period. So this complex trip of being able to do these things that we know the data tells us that women primarily do is not being supported by the public transport system. So this is a really interesting piece of work that helps us explore different lenses around who the city is for and how we're designing our kind of fundamental structures of the city. So just end on these 2 points. I think these 2 examples help to share kind of an efficient analysis to then provide an entry point for further action. So that was the example from the Sponge City Index, and using AI to help quickly understand the different land use typologies at a high level across multiple cities. And then the second example, going into a little bit more detail around the data, helps us question these business as usual practices around designing transport networks for peak for these jobs that are primarily supported by one or frequented by one gender. So it enables us to rethink and shift our practices and our ways of understanding the city to then come to more inclusive cities. So I'll end there and look forward to the discussion. Thank you very much.
Thank you, Xavier. Your talk was really insightful and interesting. The practical knowledge that you possess taught us a lot. And I think we now come to the next session is the comment from the discussion. Well, I would like to invite first discussion, Ibeng, perhaps you will have a comment on this, and 10 minutes maximum, please.
Good morning, everyone. And thank you for having me in this webinar. And thank you, Pak Haryo, for inviting me for this event. And good night, good evening, yeah, for Andreas in Boston, maybe.
Yeah. Hope he's still here.
Yeah.
Still there.
And then everyone here, maybe good morning. And yeah, I think this event is very important contribution, not only for our development of our knowledge in common campus, yeah, theoretically or practically, yeah. And also it is very important for professional and also for official, especially local government or central government. So I will start looking at more general response that although like Andreas explain everything about the recent development of using big data and tools like artificial intelligence tool. Artificial intelligence is not news. It can be back to 1960s, been developed for small scale computers. Now having a lot of source of data that come from a text, voice, image, even videos moving, yeah, something like you can look at from a camera, and then you can analyze what kind of objects that can be people, cars, bicycle, anything. You can look at carefully, and then you analyze how they related to each other. And then having longitudinal data like land use change over time. And then it's really interesting that what Andreas doing in New York or in Los Angeles. He's tell about changing land use also affecting how people consume pedestrian food behavior. Actually, my research area is also travel behavior, but not looking at more individuals, big data. Yeah, talking about, although in this case, he talked about 40,000, something like that. Of course, looking at other research that Maya is doing in Indonesia, based on her dissertation research, actually in Hiroshima. I was at the time his external examiner for his or her dissertation. At the time, of course, it's really important issues that how that kind of interconnected internet issues, and then developing of application about travel of individual using ride hailing, how that affect the urban form expansion or shrinking or something like that. It's very important analysis to help policy planners, yeah, how they will deal with the problem issues in urban problem. Similarly, also Pak Ridwan give us a more perspective how that current research being direct thing to current issues especially in developing countries, commonly also in developed countries. And then similarly, what our friend from Arup, what is her name? I forgot. Sapia is also have a good, give us a great idea about analyzing transportation in urban area. Yeah, looking at the network, path network, or social road network in the cities. There's many examples that being emerged, yeah, recently in many literatures. Yeah, can you move a little bit? I try to look at more on general perspective of development of big data and AI. So can you move that to next slide, please? I'm not handing that.
Okay.
Okay. Can anybody read that thing? Okay. Thank you. So we cannot avoid that. the big issues in developing countries, especially in Indonesia, what I'm saying is we are trying to connect the dot. I have been 3 years almost teaching class of computational thinking and data science in this school. And then I'm having difficulties trying to give them the perspective how that kind of computation and data science will help us understand the issues, the complex issues in urban development. So I start always something like this first, trying to connect those problems, connect to where the AI, artificial intelligence, and then also using a big data. So how you connect that? They don't understand. What they are thinking is they have to learn about coding. They have to learn about how to manage database, access database, and calculate that. What I'm saying to them that, of course, you have to understand how planners using tools. Yeah, almost planners has a good idea. GIS tool, spatial analysis is already in their pocket. But now, using so many tools that are available, whether it is open source, you have to develop yourself. Yeah, of course, you have to come back what issues that you are looking at. So let's move to this complex challenge, urban development. I'm trying to put two eminent persons. First of all, is Michael Beatty, the professor of Mbak Zahra here. That's right, Mbak Zahra? And also a friend of Pak Haryo. So the first one is what he says that fast emerging as the core set of tools employed to deal with problem data and urban simulation. And then the second one is also, I know him. He lives in California. He's the director or own the GIS S3. He's a good child, of course, right? So it is also mentioned by a friend of Michael Beatty too. So what he says that exploit the vast new data resources that are becoming available from social media. So what we are having on the right side of the slide, you have sensors, IoT, available in any area of cities right now, right? And then anything, many tools. Can you move to next slide? So this is implementation issues that implementing and big data in Indonesia. I'm not going to say every one part of this, but just give you some general idea. So recently, we see that a lot of cities develop what we call central hubs of data. What we call is common rooms, right? The common room, DKI Jakarta, Bandung, Surabaya, Medan, we are pushing them to have a common rooms. Actually, the common room is eyes, or what you call a big brothers. And you see the movie, there's a big brothers looking at you everywhere. But first of all, what they are using the center hub, the data centers, is more on the traffic activities on the network, on the road network.
2 more minutes, Pak Ipeng.
Okay. So they are looking at, for example, issues, traffic violation, traffic violation, traffic volume, or something like that. And then simply for, the goal is to improve the quality of traffic, okay? That's more microscopic view that we can get similarly from what Andrean and also what's it called again? Safira said, and also problem microscopic issues, Mbak Maya too, But if you looking at how that the local government did for this kind of big data, not having like common room, but they're trying to more proactive way. For example, in Jabar, there is a way that greeting people. Greeting people meant jabar menyapa or something like that. Using a big data with your application where the stunting problem from household is very difficult to get the data. And then the approach is not the way that we are talking about big data or artificial intelligence, but to get crowd source of data, also a big problem in Indonesia. So what Jabar's trying to do is proactively, they give some kind of intensive to local household to get a meal. If you register yourself, you will get meal every week. And immediately from 15% to 65%, people join the Jabar Menyapa. So really help. That's kind of things also part of innovation. Not merely only talking about AI or big data, but trying to connect people. Using this kind of technology, also important thing that we are thinking about starting this. So that this area that people talking about more on research, developing tools, but the other way around, we have to talk about how the government use that kind of situation in the environment. We're trying to push them to answer those, the first that I put in the first slide, lot of challenge that we can help local government, help our research. It's not only about the tools, but also about governing them. How we govern that. For example, it's very simple approach, just greeting people using this technology, and you get all the big data. And having the big data, you can do whatever you want. Using artificial intelligence, statistics, machine learning, you can get new knowledge of that. I think I stopped there, but thank you very much.
Thank you, Pak Ipeng. Very interesting. Next, Zara. She is from King College, and we are happy that she is here now. So please, you have 10 minutes. No, you have to use this. You can use this. I have this.
Thank you. Hi, can you hear me? Okay. Thank you so much for Pak Haryo, for inviting me and everyone from SAPPK ITB. And thank you as well for all the presenters today for such an engaging and exciting talk as well. So in this discussion session, I will be adding a couple of things based on what Pak Ipeng has mentioned. And I think it's great to see different kind of presentation, different kind of research that has leveraged AI and big data for urban analytics. I myself have been working on such topics. So in the field of urban analytics, spatial data science, and data-informed, data-driven urban planning. And so it's good to see that there are some sort of consensus in terms of what is important and so what needs to be taught in terms of using this kind of tools. I would like to just start by highlighting some themes that emerge from the presentation, because I see that based on the 4 presentation, I don't have any slides. I'm just going to comment on the presentations that has been done. We know that urban design, urban planning require a holistic and comprehensive approach. And so artificial intelligence and big data analytics, I think we need to think about it as an opportunity. We can leverage it, but it's only provide a tool to understand, to advance urban planning, urban design, and policymaking processes. We need to underline the fact that it is a tool, and it's really up to planners, it's up to designers, and it's up to policymakers in terms of how to utilize them. And it's important that we do understand how to properly apply the technique to be able to inform this urban planning and urban design, and understand what are the limitations that follow in using this kind of data and this kind of technique. So I feel like the 4 presentation has given us an overview. It gives us an example according to what data-driven, or according to Safia, a data-informed urban planning, urban analytics, or what we call an AI-driven planning. And we can see that there are many opportunities. We can use it for land use prediction, transport, pedestrian modeling, and I think the list goes on. And each and every presenter has provided excellent examples in terms of the kind of approach that has been done. I would like to first comment on Pak Ridwan's presentation that has given us quite a nice overview in terms of the kind of body of literature as a proxy for awareness of urban analytics, or the kind of research that has been using urban analytics, especially in academic setting. So even though the topic seems to be more prominent in the global north, so we can see that it's more prominent in countries such as US, China, UK, Europe, but there is an emerging trend in the countries of the global south as well. And we need to understand that it might be different, the kind of challenges, such as what Pak Ibeng just mentioned, the kind of challenges that happen in countries such as Indonesia and in countries in the global north, such as the US or the UK. And it's good to see that based on the body of research, we can see that the evolution of urban analytics is actually leaning more towards a human-centric approach. There is more understanding that human is in the forefront of whatever tools and techniques that we are using. And now I'm going to comment on Maya's presentation as well. I think it's excellent in terms of trying to utilize this kind of emerging data set. In this case, it's the multi-service platform in which this MTSP, or multi-service MSTP, the multi-service platform, it allows us to match the rider's needs and the driver's need, right? This kind of app is often called the network orchestrator, because then the app connects these two entities. And in this case, the use of a motorcycle fleet that in the past is highly informal. In the past, it's very hard to be able to understand what is the behavior of the people who are using this kind of like informal transportation. But using this emerging data set, such as in the case of Maya's research, she's able to see she's able to do this spatio-temporal modeling, spatio-temporal analysis and exploration in terms of what kind of activities have been emerging in the city of Bandung. And we can understand this kind of informal form of transport in terms of how it has been used, how it has been utilized, how people are connecting with this kind of services using this geo-reference locational data. So the use of this kind of emerging data set is something that the planners might be able to explore further. And I think in terms of Safia's and Andres' presentation, there are some linearities in terms of the kind of research that they have been doing and the things what's being discussed. There is a bit of discussion of generative AI, because now we live in the world in which generative AI is everywhere, with the use of ChatGPT, with the use of the all kind of generative AI that can model different kind of like image, sound, ambience, and so on and so forth. And there's also a bit of discussion in terms of combination of satellite imagery and machine learning, as well as AI for data generation. And I think that's an important aspect that we need to understand, that if the data is not there, then these tools and technique can actually help us to be able to generate new data. For example, the sidewalk width that Andres has mentioned in his presentation, I think it would be very useful in terms of trying to understand how the city activity, the city metabolism, and the kind of design that can be used for efficiently and effectively by the people. It touches upon the topic of this low carbon mode of transport, accessibility, trying to look into the accessibility analysis in terms of understanding how city works. And those are the topics that is of importance, because then in order to understand our city, first we need to explore the behavior of the people in the city, and then we need to also explore what is the network, the kind of built environment. After we understand all that, using the available data, the data that we can generate using machine learning and AI, then we can start doing predictive modeling to try to be able to understand what kind of city that we are trying to build and simulate scenarios, we might say, to see if that city would work. It could help us understand who benefits from the planning and the development, and if planning and development and design actually helps vulnerable communities, for example. Are the vulnerable communities being advantaged or being disadvantaged by the urban planning? So I think it's very important to start thinking about that, especially for the young generation of planners who will be planning for the cities in the future. And I think based on Safia's and Andres' presentation as well, I would like to echo Andres' statement that says that we need a sense of focus, because we need to think about what cities do we want and who the cities are for. And we can't do that by if we don't understand the kind of how the city works. And AI and big data analytics actually provides a tool to understand how the city works. And planners should try to think more innovatively in terms of understand, thank you, the urban problems more systematically as well. And we can start to be mindful in implementing the kind of urban planning and design that would be more equitable, healthy, sustainable. So in Andres' words, it's a different mitigating measure. So instead of using the data to do the kind of urban planning that try to support, for example, more traffic, we can actually shift the kind of planning to a more low carbon transport, for example. So while we see there are many exciting opportunities of how big data analytics can be used for urban planning, we need to also understand the limitations of the approach. The main potential barrier would be data accessibility and accuracy. So often, especially in Indonesia, the data are not available. And AI and big data analytics, actually, the system is some sort of like rubbish in, rubbish out. If your data is rubbish, then the result would be rubbish as well. So we need to ensure the data quality, the data accuracy is also good. So then if we can see from the presentation, if the data is not available, then we can generate the new data. And this kind of new data should be made open, should be transparent, and should be able to be replicable, reusable, rescalable. And this kind of mindful, like this kind of mindset should be have by the planners and designers. And so as a closing thought for me, because I'm aware of time, I would like to highlight that AI and data analytics, despite their potential, cannot fully replace traditional urban planning. What it can do is actually to add into the traditional urban planning. So then it can be combined with a more traditional method of urban assessment, and we put people in the forefront of urban planning. Also, planners cannot work alone because a collaboration is needed and it's vital. And the new generation of planner should also be mindful of this collaborative and innovative ethics, and should be equipped with the right skills and knowledge. I think that's it for me. I think that's a vital element to enable the plans, a successful urban planning and policy implementation for a just, equitable, and inclusive cities. Thank you so much.
Thank you. Thank you, Sarah. Well, now we come to the last session is for question and answer. But before we start for the floors of the Zoom and the floor here, I would like to have perhaps a response from Andres. I don't know whether he is still here because now it's almost 12 o'clock there. So very nice. But if he is still here, I would like to have his comment. No, I don't think he's here anymore.
I'm still here. Yes. How are you?
Thank you.
Thank you.
Thank you very much.
Very briefly, I was just about to log off, actually.
Yeah, please.
No, I don't have much to add, but in light of these concerns, so I think we are a bit in a bit of an echo chamber that planners are predisposed to care about social qualities of cities, but this by no means means that all of AI research, where it comes to urban services and applications, has the same starting point. In fact, what I see in sort of daily practice and daily work is that most of AI-driven work is, in fact, as you would expect, driven to invent new services to sell to people. And I think this has very important consequences for cities. And I think it is an important challenge lying ahead, how to maintain control of that narrative, or at least center the public qualities of cities, rather than making way for ever-growing technologies to sell services to people in cities, and whether they're automated vehicles or other automated technologies that change existing services. I think that's something that seems an important concern to me, and I think one way to think about it means that we need to make sure that the public sector has a strong voice in this. And this can be very difficult because oftentimes the public sector can be hard to trust, or can be inefficient, and so forth. But I think at the end of the day, cities are for everyone. We need to plan them around public needs and everyone's needs, and should not really be conceptualizing cities as ways of kind of making way for new technologies. So that so this has been echoed, I think, in multiple presentations today, and I think it's an important takeaway for all.
Thank you very much, Andres. And if you want to, like, of course, now it's 12 o'clock there. We are all thank you very much for your participation and giving a lot of knowledge for us to learn. And yes, thank you very much, Andres.
Thank you. Good night.
Good night. Next is if you want to have a comment, Maya or Pak Ridwan. No, Savia, perhaps you will give a response of the comment from Pak Ipeng and Bu Zara, please.
Yeah, I think the presentation slide on the multiple complexities of the city is always quite overwhelming as an urban planner, both probably as a student or a researcher, as well as a practitioner. And I think the ability to kind of access data and put different parts of data together is also an opportunity to help see how we might be able to develop strategies or solutions to help think about how you could deliver something to meet multiple of those challenges. So I think maybe we might get overwhelmed by some of the complexity, but let's also see the opportunity in that. And yeah, I mean, I think agree just with the sentiments from Zara that we do have this responsibility to focus on the opportunities for focusing on the ambitions of the city that I think Andreas also highlighted around the livability elements and the inclusive cities for all. I mean, I think that the challenges that Andreas just highlighted, that there are different perspectives in the city. And I think, you know, that consideration of multiple lenses and multiple benefits is also important there. So maybe, for example, a private developer, their immediate focus might not be on delivering public good, but being able to connect the public good to also the economic benefits that they could also receive is also an important link there. So I think we also need to keep working on different language and to be a kind of positive outcome for all.
Thank you. Thank you very much. So now let's start with the question and answer. Well, first, I will open it from floor here. Perhaps there's questions. One here, two. Uvenita, because we have now also a National Open Forum here. We will have a workshop after this with the topic around this, what we already discussed. Siapa namanya? Abdul. Abdul. I always forget Abdul. Abdul. Another who Andani, Bu Pipin, I think you are all also involved in research like this. Perhaps you have questions? Pak Bagas? No? Okay, Abdul, please. Pak Dini.
Thank you, Professor Haryo, for the my question opportunities. Thank you for all the speakers for the outstanding materials. I would like to ask my question, apart from how we view AI and big data analytics in urban studies, I would like to ask for a suggestion about how a researcher from urban planning or urban studies field to view or position themselves in this kind of emerging research fields, which is the AI and big data analytics. For example, should they start to learn to code, for example, in order to be able to develop the models themselves, or whether they are generative or analytics, maybe, perhaps, or should they always collaborate with other researchers in the more relevant fields, such as the informatics or computer science or engineering? Thank you very much.
Thank you. One more, if we have a question here. No? Okay. I think there's one question here from the Zoom, from Rinaldo Devi. Yeah. How is AI evolving and how might it impact urban development in the coming years? Speculating on the future possibilities. Well, I perhaps these two questions first. I think, well, you can give an answer first, Maya. Perhaps you have an answer for all these two questions.
Sorry, maybe can you repeat the first question?
The first question is how the planners should position themselves in this field like this.
Okay, a field of the AI-based
yeah.
planning. Okay, so based on my opinion, I think this is my personal point of view. As a planner, regarding to Ms. Zahra comments, I also agree that we need to make our positioning ourselves as a planner is the main decision maker for planning. So I think for the at least 5 or 10 years, the urban analytics or AI-based evidence planning is still in the state of tools. So we cannot rely 100% our decision just from the evidence base, but we need to have some interference. We need make some decision based or on our knowledge, not only from the evidence. But for the second one, how AI evolving and how might the urban impact the urban development, I think it depends on which field that AI present. I mean, from my research, the AI present in the transportation fields also it will affecting how people's behave, how people choose the mode and others. But if AI present in the educational like ChatGPT or others, it might not directly affect the urban development, but it might be indirectly in some part that we cannot see physically. Maybe that's from my opinion.
Thank you, Maya. Perhaps the first question from Abdul, Safia will have an answer of you because she is in the practical as a practical planners. Please.
Yeah, I think it's a really great question. Maybe if it's okay to answer a little bit of both. I think it's really important to be a kind of wide generalist as an urban planner. I think, you know, it's really important to have these different perspectives, and you're the kind of conductor of bringing these things together and then working with different actors in the city. So I think, you know, there's an opportunity to, at least I think as a baseline, have an understanding on how you might be able to use these different tools, and to really be able to ask those right questions. And I think also Buzara highlighted this, that we're kind of needing to have the context around what data is coming in and what data we need to start to collect or detail out to understand the city, and then to kind of frame those questions so we're using these tools in the most efficient way. But I think if you only have a kind of high level view on these functionalities, then you need to be very close to the people that can do things in detail. And I think that's the opportunity of collaborating with either academics or people from other sectors. If, for example, in Arab, there are people that have great depth in, you know, these different AI tools, but we need to work hand in hand to make sure that they're relevant and contextual. Otherwise, you know, they'll just go and develop the electric vehicle that still generates all of this congestion, etc. So if I could say a little bit of both, making sure you have the overview, but then sitting very closely with those that have the depth.
Thank you. How about the second question? What the future possibilities?
Yeah, I think opportunities are endless. I think probably they will become more smart, and it'll be a little bit more challenging to separate that kind of human or creative element that we say is really distinct from humans versus the machine. So I think then it'll be even more important to be really aware of what data is being fed into these different models, to make sure that we're not creating or enhancing stereotypes or bias or exclusivity. And then also being really aware of how to use these different tools. But I'm sure other people have different prophecies on how AI will develop in the future.
Yeah, thank you. Farid, what do you want to?
Yeah, I would like to add some. Maybe I would like to. I still remember a few months ago, people from Britain come to my office. They asked about first few months ago, and then around months ago, from the Center of Research and Development West Java come to my office. They asking about what kind of AI appropriate to develop regional development for the national level and then from the regional level. In that case, I show that we still have a black box in planning. The first one in terms of developing urban problems, just like what I have been presented, that we have unpredicted values, unpredicted environment, and unpredicted decision-making process. Another thing is that in the process of formulating planning. So I would like to show some one. So in Indonesia, maybe in practical, we are focusing on straight what is the output of the product. For instance, for long-range planning for RPJP, for instance, long-range planning development plan or mid planning development plan, or for regional planning document like RTRW or RDTR without first try to formulate what kind of problems that we have. So it is important for us first to identify what kind of problems. At least there are 5 problems that we have to deal with planning. For instance, the first one, if we have to choose the treatment of scope, treatment of complexity, the third one, treatment of conflict, treatment of uncertainty, or treatment of progress. This makes the whole process in planning will be more smooth. So we have to first, if we have to formulate, or the character of the problem is the treatment of scope, that the data that we have to deal with is need more focus and then more synoptic. But if it's come to the second problem, treatment of complexity, then the data should be more simplifying, and then more the result is more elaborating. The third one, if we focus on conflict, so we need the data for more reactive and then more interactive. The fourth one, more reducing, more accommodating, and then the easiest one, the fifth one, with fifth variance to more exploratory, then the product is more decisive. Maybe that's all, Pak Haryo.
Thank you. I think we still have 4 minutes. I need to have Pak Ipeng and Bu Zahra to comment.
Ya, saya kira bisa. Yang pertama, satu hal yang mesti ngerti dulu ya. AI, apa bedanya AI dengan traditional software gitu. AI itu di mana rule-nya itu yang membuat data.
Perhaps you speak in English, please.
Oh, I'm sorry. I'm so sorry, Pak Haryo. I think you have to know exactly the difference between AI and traditional software. Actually, this message is come from the UN Undersecretary. He is a director of AI development in the world. That what his message is, it should be very careful, because when you develop AI, meaning you create the experience, the behavior of all people become rules. That's the opposite side of traditional software. You create a rule and you input data, you get output. But the AI, just like ChatGPT, what Zara said, the AI machine learn for your question, and the answer they're trying to give it to you, and you agree with the answer, you will improve the knowledge of the AI itself. For example, I give you a problem with building permit in our case, where for specific regulation, we trying to reject that kind of permits. And then under situation where the knowledge about this creation that we give it to, that we allow that permit, that experience become part of experience and become of the knowledge. And when there is new situation that's similar to that kind of problem, people maybe forgot whatever decision they have been made, right? According to the AI, they have the own rule. That kind of situation will come up again, and then immediately an AI will give you answer. Imagine that complexity of cities where the whole experience being connected and then become a part of all knowledge. Your rule is obsolete for regulation or whatever, and now there is no knowledge about what Pak Ridwan says. There's become a regional knowledge or everything. And then, of course, and then the second one, the answer of the second question, I think the hyper-connected people trying to, what I am saying about, I give you example about Jabar Menyapa. There's kind of the connectedness, hyper-connectedness that never happened before. That people from computer science, they do not understand that. So we give them question. Can you answer? Can you create such knowledge about this? For example. So you can work with the computer science. You can work, but they simply provide you with the tools, but the questions come from you. So you are triggered the new knowledge about how the computer science will evolve. So not come from themselves, but come from the needy, from us. That's what we work together with them. That's what we call urban analytic. Even MIT create two those knowledge, urban science or informatics together with urban expert. So that now they create new department, urban analytic department that consists of planners and also mathematician. Thank you. I think I have your answer. Thank you very much.
Zahra.
Yes, thank you. Very interesting question. So I just would like to add, because urban analytics is such an interdisciplinary knowledge. So usually people have their domain knowledge. For example, the domain knowledge for you might be urban planning, but then they also have the skills, which are the coding skills. It might be that they're using GUI or like the user interface. So it doesn't have to be coding. There are some GUIs available as well, softwares, GIS, to do this kind of analysis. However, it relies on, but then the problem becomes like, how flexible do you need to be? If you are dealing with a big data set, 20 million data set, it's impossible for you to be able to use a GUI tools to analyze it. So then you need to go towards like using the softwares, Python, SQL, and all that. But then if you don't have that kind of skill, then you can collaborate with people who have that kind of skill. And in urban analytics, actually, if we try to filter out the kind of knowledge that are needed, there are quite several of them. So you need your domain knowledge, which is, it might be your urban planning, you need your statistic, you need your coding, you might also need, if it's design, it might be architecture, it might also be, so there are lots of different things that, sorry. So there are lots of different things. So then you do need your own skill, but you also need collaboration if you want to do a study that's quite complex. So I think in terms of the next generation of planner, the skill is still important. For example, at King's College, we do have the department, I'm in geography department, but the students, the BA or BSc student, they can choose a pathway, which is called a spatial data science pathway. So people who are quantitatively driven, they have the choice to be able to learn more in depth through 3 courses in the use of Python for urban analytics, for example. And that's just one example of how this has been done. So if there is an interest in terms of the use of coding and such, I think the skill should be acquired, but it's not something that every planner have to have, because they can collaborate. I think that's my standing on the first question. On the second question, wait, I can't see the, sorry, how AI is evolving. I think AI is evolving already. For example, for the use of generative AI, now it's very easy to teach students, for example, in the use of the Google Earth engine, because you don't need the basic, even the basic codes that can be used for the Google Earth engine, you can generate it using the generative AI, such as ChatGPT. So then you can use that codes, you can then extract the data, you can model the data. So I think the use of AI can actually be quite useful in the teaching environments, because then it actually makes things, it can actually be used as a tool to advance the skill of the students. And that's in the academic setting. In the non-academic setting, for urban planning and development, for example, it becomes easier, for example, to do a scenario simulation. So if we do a design, we do a planning, and then we want to know how many people that will be generated in terms of the foot traffic. What is the traffic is going to look like if a building has been generated? How many employment activities that can be generated? How many additional housing that is needed? All that can be done using this kind of tools and analysis. And so we can start thinking about this is what it might look like using the predictive analytics. So then if this is what might look like, how many housing that we need to be built, that needs to be built. So I think, again, it's a tool. It's up to us how to leverage it, but it's an exciting tool, and it's something that can be used efficiently as well and can be beneficial for urban planning processes.
Thank you, Sarah. I think we have to stop, unfortunately, because it's now 11 and we will have another workshop with the National Urban Forum here already. I think I want to highlight 2 or 3 points. First is that AI and big data, we have to see that there are 2 different infrastructure, the hard infrastructure and the soft infrastructure for this. The hard infrastructure, the way you have the tools and so on. But the most important is the soft infrastructure. This is the people who will use this. If it's in the academic, then we have to know. And now I think we have to change how the way we teach, because everything is there. You can ask the coding for everything from ChatGPT, like Sarah has just mentioned. On the governance, then like the question Ridwan just mentioned also, the government will ask what AI that we need. No, I think that's not the question, but how people are really understand and know how they can use this AI for the cities or for the regional. Well, I think that's the takeaway that we can get today, and I would like to close this with thank you very much for all the participation, all the speakers, and please give a round of applause. Thank you very much. Thank you. And I think, okay.
Okay. Thank you so much, Professor Haryo, for giving such a very wonderful, insightful materials and discussion. And also thank you for all the speakers, the discussions, are also for all the participants who are already involved in our very attractive discussion. So I hope we will get more knowledge to do more research or something that will helpful in our build better environment. Before we end this webinar series, as usual, we'll have some photo session. So please, for the participant who already stay here, please come forward. And for all the speakers, moderators, and discussions, I would like to invite to move forward in front of your tables. And for all the participants who stay in Zoom, please turn on your camera because we will have to screenshot your participation also. Yes, please, for all the participants, please come forward. In front of the tables. Please, for all the participants. Okay, please, for all the participants, please come forward. Because the participants who stayed in Zoom already turned on the camera. So please, for the participant who attend in this room, please come forward. Please, for the participants and speakers, moderators, and all the discussion, please make 2 layers in front of the tables. Okay. Yes, please. For the speakers, the moderators, the discussion, please be seated in front of. For Pak Petrus, please. Pak Ibeng, Pak Ridwan. Cek. Bu Pipit, Pak Denny, Bu Andani. Okay, for all the participants in Zoom, please be ready. For those who haven't opened your camera, please turn on your camera right now because we will start to take your pictures. So I will count from 1 to 3. Be ready. 1, 2, 3. One more time. 1, 2, 3. Okay, one more time with pause. Yeah. Okay. 1, 2, 3. Okay, thank you very much for all the participants, especially for the speakers, moderators, and discussion. And before I officially close these webinar sessions, I would like to remind for the invited guests to continue join the National Urban Forum. So please join the Zoom meeting link. They're already provided in the Zoom chat and already provided by the invited documents that already sent to the invited guests. Once again, I would like to remind for all the participants who already being invited by the National Urban Forum, please move to the another Zoom link because we will continue to the Zoom link after this directly.
Ya, dia mah orang bule ya. Kita malu-maluin ngomong terbata-bata.
Saya itu bahasa suka dan
bawa-bawa.
Okay, thank you so much everyone for attending this webinar series for SAPPD. So,
okay.
So for non-invited guests, please leave this room because we will continue to another meetings.